Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0123, signals a high voltage situation within the throttle position, TP sensor A circuit. This error indicates that the voltage output from the TP sensor A is reading higher than what is considered normal, which may lead to performance issues in the vehicle. Throttle position sensors are crucial components in the vehicle's electronic fuel injection system, as they inform the engine control module, ECM, about the position of the throttle plate. Located on the throttle body, the TP sensor helps to adjust the air-fuel mixture needed for engine control. If malfunctions occur, they can compromise vehicle power, fuel efficiency, and emissions output. It is critical to address this issue promptly to avoid excessive wear on engine components or further damage to the vehicle's performance systems. This DTC reflects a high voltage detection in the throttle position, TP, sensor A circuit. The TP sensor is located on the throttle body, which is butterflies that controls the air intake to the engine. This sensor monitors the angle of the throttle plate, thereby communicating to the engine control module, ECM, the current throttle position. In the context of DTC P0123, when the voltage output from the sensor exceeds the expected threshold, the system recognizes this abnormality, indicating a potential fault. This sensor is vital for managing engine performance, including managing the air-fuel ratio and adjusting the timing of fuel delivery. A failure in this sensor can severely disrupt normal engine functions, leading to reduced performance or potential damage over time. Several potential causes can lead to DTC P0123. A primary concern could be a malfunctioning TP sensor A itself, which might send incorrect voltage readings due to internal component issues. Wiring problems represent another significant cause. Frayed wires or detrimental connections can impede signal flow and lead to high voltages being read. Additionally, loose connectors at either the throttle body or the powertrain control module, PCM, can result in intermittent signals that disrupt normal function. Finally, while less common, a malfunctioning ECM can also be responsible for erroneous readings from the sensor. Careful inspection of each of these areas is essential to pinpoint the root cause of the DTC. The symptoms associated with DTC P0123 can have a profound impact on vehicle performance. Drivers may notice poor engine performance, with a significant drop in acceleration response when pressing the accelerator pedal. Erratic acceleration is another common symptom, as the engine control system struggles to optimize performance due to inaccurate sensor readings. This can lead to higher fuel consumption, as the engine may be running inefficiently as it attempts to adjust to fluctuating data from the TP sensor. Furthermore, the check engine light will typically illuminate on the dashboard, alerting the driver to a potentially serious issue requiring immediate attention. Understanding these symptoms can aid drivers in identifying problems early and addressing them before further complications arise. To commence troubleshooting for DTC P0123, begin by turning the vehicle ignition to the on position without starting the engine. This allows the onboard diagnostic system to initialize. The next step is to use the Honda Diagnostic System, HDS, to clear any stored DTCs, including P0123. Once cleared, turn the vehicle ignition to the off position and then back to the on position to trigger a check of the current parameters. At this point, verify the voltage readings from the TP sensor A with the HDS. You should observe a voltage reading of 4.8 volts or higher, which indicates the sensor's operational status. If conditions match the threshold, continue with the following steps, as they indicate that the system is actively working correctly. If not, investigate for any intermittent failures. The second troubleshooting step is to evaluate whether there are any additional pending or confirmed diagnostic trouble codes via HDS. This step provides more comprehensive insight into any underlying issues that may be contributing to DTC P0123. Specifically, investigate if DTC P0223, which signifies a fault in TP sensor B circuit, also appears in conjunction with P0123. If both codes are present simultaneously, proceed to Step 5 for more detailed investigation. If only P0123 is indicated, follow the path outlined in Step 3, targeting more specific areas for fault isolation. This step is crucial, as certain DTCs can signify interconnected issues within the vehicle's signaling system. In Step 3 of the troubleshooting process, start by turning the vehicle ignition to the off position. Next, disconnect the throttle body 6-pin 6P connector, halting any input from the throttle position sensor. After this, turn the vehicle ignition back to the on position to trigger the system without the sensor input. Utilize a digital multimeter to precisely measure the voltage between two specific test points. No. 6 on the throttle body connector and the vehicle's ground. Under normal conditions, this voltage reading should hover around 5.0 volts. If the measurement confirms the voltage reading is correct, it's an indication that the wiring and PCM path are functioning properly. Thus, the throttle body likely requires replacement. If not, progress to Step 4 for further investigation. Step 4 involves testing the continuity of the THL1 wire to ensure there are no open circuits in the wiring. Begin by turning the vehicle ignition to the off position again. With the HDS, jump the SCS line and allow more than 1 minute for this process. After this, disconnect the PCM connector E, which has 80 pins in total. Following this disconnection, check the continuity between test points located at female terminal number 6 of the throttle body connector and pin number 50 of the PCM connector. A continuity check indicates whether the wire between the throttle body and PCM is intact. If continuity exists, the THL1 wire is functioning correctly. At this point, refer to any authorized service information for related issues, or consider substituting a known good PCM if problems persist. If continuity is not established, proceed to repair an open in the wire between these components. The final troubleshooting step checks for continuity in the SG3 line, which is critical to signal transmission between the throttle body and the PCM. Start by turning the vehicle ignition to the off state. Again, use the HDS to jump the SCS line and let it rest for more than 1 minute. Following this, disconnect the connectors from both the PCM and the throttle body. Then, check for continuity between the throttle body female terminal number 3 and PCM pin number 76. Confirming the presence of continuity here signifies that the wiring between the throttle body and the PCM is intact. In cases where continuity exists, no immediate repairs are necessary. However, consult authorized service information to uncover potential related DTC or symptoms. If continuity fails, then there is an open circuit in the SG3 wire that requires prompt repair. After completing the necessary repairs, it is crucial to verify that the corrections made are effective. Start by ensuring that the Diagnostic Trouble Code P0123 has been successfully cleared from the system using the HDS. Following this, conduct a test drive to monitor the vehicle's performance under normal operating conditions. During this drive, pay close attention to whether the check engine light remains off, as this can indicate successful resolution of the issue. Also, observe the engine's responsiveness during acceleration and overall performance, ensuring that it operates smoothly and efficiently without any irregularities. Monitoring behavior after repairs is a critical practice, as it provides assurance that the repairs addressed the underlying problem instead of just masking the symptoms. Preventive maintenance plays an essential role in extending the lifespan of the throttle position sensor and associated circuits. Routine diagnostic checks should be established as part of regular vehicle maintenance to quickly identify and address any emerging issues. Additionally, visually inspect all connections related to the throttle body to ascertain that they are secure and free from corrosion or damage. Periodically cleaning electrical connectors ensures that they maintain a good connection and helps prevent issues related to interference from dirt or moisture. As automotive technology continues to evolve, keeping the vehicle's software updated is equally important, as new updates can help enhance performance and eliminate known bugs or faults in the system. These preventive actions can significantly reduce the likelihood of experiencing problematic DTCs like P0123 in the future. In conclusion, the DTC P0123 highlights a critical issue with the throttle position sensor A circuit that requires immediate attention. A high voltage reading from this sensor suggests potential malfunctions that could impact overall vehicle performance and fuel efficiency. Following a thorough diagnostic procedure is essential to accurately determine the root cause of the problem, whether it be a faulty sensor, wiring issues, or related electronic control signal problems. Addressing these issues through detailed troubleshooting ensures that the vehicle remains reliable and operates efficiently. By implementing these recommendations and performing regular checks, vehicle owners can enhance reliability, minimize the risk of severe failures, and enjoy smoother driving experiences in the long run. Please like and subscribe to the channel. See you next time.